everyone, let's look at some applications involving power equations. These hopefully won't be anything too terribly messy, but it'll have you play around with plugging into power equations and sometimes having to solve. So the one that we're going to work through is formula is given for the time it takes a pendulum that is length L to make one complete cycle. So all the way from one side to the other and back. The first question asks how long the pendulum needs to be if we want it to complete one cycle in 2 seconds. So we're being given a t value in this problem, which means back in our equation we'll replace the t with 2, and we'll have that equal to 2 pi times the square root of L over 32. And this, just like our power equations, will just be a reverse order of operations type of problem. So if we start at the L, the first thing happening is the dividing by 32, then the square root, and then multiply by 2 pi. So the first thing we're going to get rid of is the 2 pi, and then we'll get rid of the square root, and then we'll get rid of the 32. That 2 pi is attached by multiplication, so we remove it with division. And I will simplify just a little there because it's an easy one. I can cancel a 2 out, and I'll get 1 over pi equals the square root of L over 32. And now I'm ready to remove the square root. Again, think carefully about this. I think just sometimes people kind of autopilot, and when they're trying to remove a square root, they square root the opposite side, and we're using inverse operations. So if we want to remove a square root, we need to square both sides. So I end up with 1 over pi squared, and you could leave those parentheses, but I feel like we may as well start cleaning that up just a little bit as we go. All we're left with on the right is the L over 32, so our final step is to multiply both sides by 32, and I end up with 32 over pi squared. If you need the reminder, that's 32 over 1, so that 32 will end up in the numerator, and that's our L value. Since this is in the context of a word problem, it's a good idea often with those to convert that to a decimal just so you can get a sense of if it's a reasonable answer and what you're actually saying about the length of the pendulum. So it's great to see that exact answer. Don't round on the steps along the way, but when you get to that final answer, an approximate would be great. For this one, I got L is approximately 3.24. And if we look back at our units, L was the length of the pendulum in feet, so that should be feet. So this is a kind of typical thing you'll have to do, and in some problems you'll actually have an additional step where you solve the formula. So this is basically one of our literal equations. So the steps will actually be identical to what we did up above. We'll just have the t variable still in this problem. So we have the formula arranged so that we input the length of the pendulum and it outputs the time for one cycle. We're going to solve for L, and that will give us a function that inputs the time to complete a cycle and outputs the length of the pendulum. So we'll start just like we did last time by dividing both sides by 2 pi. So we have t over 2 pi equals the square root of L over 32. And then we can square both sides. T over 2 pi squared equals L over 32. And we can multiply both sides by 32. I'm going to do just a little bit of simplification along the way here. I'm going to go ahead and square everything in those parentheses. So I'll end up with a t squared on the top, and on the bottom I have a 4 pi squared. Don't forget the 2. Remember, if we're squaring 2 pi, that means 2 pi times 2 pi, which will be 4 pi squared. And then, I guess I'll write one extra step here. Multiply that 32 in. I can reduce a little bit. 4 goes into 32 8 times, so I end up with an 8t squared over pi squared, and that's equal to L. Or if you want to use function notation, we just found that L of t is 8t squared over pi squared, to be contrasted with what we started with, which was t of L. So if you ever start with a function t of L and you're asked for L of t, you just solve for the L variable. You solve for the input variable. So hopefully that doesn't give too much trouble playing around with those, but let me know if you have any questions. Thanks for watching.